The stench of diesel and damp earth hung heavy in the air. A familiar perfume of the Eastern Front. It was late autumn. 1943, and the ground, churned by endless tracks and boots, had become a viscous, clinging enemy. For Oberleutnant Klaus Richter, a tank design engineer seconded to the front for practical experience, every day brought a fresh lesson in the brutal realities that his blueprints rarely captured. Today, however, promised a different kind of lesson. Word had come down the line from a reconnaissance unit, an American M4 Sherman, captured largely intact, its crew having bailed out after a track was blown by a well-placed anti-tank round. It was a rarity on this front, a prize from the Western Allies, diverted perhaps to bolster a Soviet unit or simply a curious logistical misstep. Whatever its provenance, it was here, sitting like a bewildered beast in a collection point behind the lines, awaiting transport to a more suitable examination facility. Klaus, a man whose hands were more accustomed to slide rules and drafting pens than the rough texture of a tank hull, approached the Sherman with a mixture of professional curiosity and a nascent, almost subconscious disdain. German armor, particularly the Panther and Tiger, represented the pinnacle of engineering might in his eyes, complex, powerful, sophisticated. The American tanks, from what he'd heard and seen in grainy intelligence photographs, were simpler, more crude. Mass-produced, certainly, but lacking the Teutonic precision that defined their own war machines. The Sherman, a medium tank, stood before him, its olive drab paint splattered with the omnipresent Russian mud. Its cast hull, rounded and utilitarian, seemed almost soft compared to the angular, welded plates of a Panzer IV or the imposing vertical surfaces of a Tiger. The radial engine, a peculiar choice for a tank in European eyes, was a detail Klaus had already mentally catalogued as an oddity. It seemed to embody a different philosophy entirely, one he was keen to dissect and, if he was honest, to dismiss. Hauptmann Ernst Vogel, a grizzled veteran of the Afrika Korps, and now the officer in charge of battlefield recovery and assessment in this sector, clapped Klaus on the shoulder. "Ah, Oberleutnant Richter, our American guest. What do you make of it?" Vogel's tone was jovial, but his eyes held the weary wisdom of a man who had seen too much. He'd learned long ago that the enemy's machines, no matter how outwardly inferior, often held unpleasant surprises. Klaus adjusted his spectacles. Crude, Hauptmann. Clearly designed for rapid production, not necessarily for battlefield supremacy. The cast hull, the high profile. It presents a generous target. Vogel merely grunted, puffing on a short, malodorous cigar. Perhaps. But they build many of them. And they are here, are they not? He gestured vaguely towards the west, where the American and British forces were making their own slow, grinding progress. This one, at least, seems to have survived its journey. Track broken, yes, but the rest of it? Remarkably intact. Not a single penetration. Klaus circled the tank slowly, his engineer's eye already picking out details. The suspension, a vertical volute spring system, VVSS, looked robust, if somewhat dated in its concept compared to the sophisticated interleaved road wheels of the Panther. The tracks, though broad, seemed less complex than the multi-link affairs on German tanks. Everything about it screamed simplicity. The gun, a 75mm, no doubt, Klaus murmured, peering at the barrel. Adequate against older models, perhaps, but hardly a match for a Panther's 7.5cm KWK-42 or a Tiger's 8.8cm KWK-36. He paused, then added with a touch of professional arrogance, "It speaks to a different understanding of armored combat, Hauptmann, one that prioritizes volume over individual lethality." Vogel took another puff. "Volume wins wars, Oberleutnant. Remember that. 1,000 adequate tanks will overwhelm 100 superior ones, given enough time and resources." Klaus nodded, but he wasn't convinced. He believed in the decisive punch, the superior protection, the technological edge that German engineering strove for. Yet, the Sherman's very presence, its sheer resilience despite the chaos of battle, was a silent counter-argument. He ran a gloved hand over the thick, cast mantlet of the turret. The surface was rough, unrefined, yet undeniably thick in places. The commander's cupola, a small vision-enhancing blister, seemed practical. The large hatches, designed for easy entry and exit, were a departure from the smaller, more restrictive openings on German tanks. These details, small as they were, hinted at a different design philosophy, one focused on the crew and their ability to operate the machine effectively. Rather than solely on ballistic protection or firepower, the task of transporting the Sherman to a dedicated testing ground at Kummersdorf, near Berlin, was a monumental one. It required specialized heavy recovery vehicles, a low-loader train car, and a significant allocation of resources. But the intelligence value was deemed high enough to justify the effort. This wasn't merely a captured vehicle. It was a window into the enemy's industrial soul, a tangible representation of their approach to modern warfare. As the recovery crew began securing the Sherman, chaining it to the heavy transporter, Klaus felt a peculiar shift in his own perspective. The initial disdain was still present, certainly, but it was now tempered by a grudging respect for the sheer mass and apparent sturdiness of the machine. It had taken a direct hit to its track, yet the hull remained unbreached, the turret traversable, the guns seemingly operational. This wasn't the flimsy disposable vehicle he had imagined. This was a fighting machine, perhaps not as elegant or as deadly as his own nation's creations, but undeniably robust. The journey to Kummersdorf would be long and arduous, a slow procession across war-torn lands. But for Klaus Richter, it was more than just a logistical exercise. It was the prelude to a deep dive into an alien engineering philosophy, a confrontation with a different path to victory. He knew, with a certainty that was both exciting and unsettling, that the coming weeks would challenge many of his preconceived notions about tanks, about war, and about the very nature of engineering itself. The mud-splattered Sherman, a silent testament to American industrial might, was about to reveal its secrets. And Klaus Richter, the meticulous German engineer, was ready to listen, even if he didn't yet know what he would hear. The sprawling testing grounds and workshops of Kummersdorf, southwest of Berlin, hummed with a different kind of intensity than the front lines. Here, the clang of steel on steel, the whine of electric motors, and the murmur of focused voices replaced the distant rumble of artillery. It was a cathedral of engineering, where Germany's finest minds dissected, tested, and innovated. When the captured M4 Sherman arrived, a hulking silhouette on a flat car, it drew a crowd of engineers, technicians, and military observers, all eager to lay eyes on this foreign beast. Oberleutnant Richter, now back in the more familiar environment of the workshop, felt a surge of renewed purpose. His hands, though still clean, itched to begin the methodical process of dismantling. He was joined by Dr. Karl Brandt, a senior design engineer from Daimler-Benz, a man whose reputation for meticulous analysis preceded him, and Lieutenant Peter Haas, a younger, enthusiastic engineer fresh from the technical university, whose mind was a sponge for new information. Brandt, a man in his late 40s with wire-rimmed spectacles perched on his nose and a perpetually serious expression, circled the Sherman with a critical eye. A curious specimen, Richter. The cast hull is unorthodox, efficient for mass production perhaps, but one wonders about the consistency of its ballistic properties. Indeed, Doctor, Klaus replied, adjusting his own spectacles. My initial assessment at the front was similar. A pragmatic design, not one focused on theoretical perfection. Peter Haas, meanwhile, was already clambering onto the tank, examining the commander's cupola and the hatches. The hatches are remarkably large, Herr Oberleutnant. and the internal layout seemed spacious, at least from what I can observe through the open turret hatch. Spacious often means less protection, Brant interjected, his voice dry. Every cubic centimeter devoted to crew comfort is one not dedicated to armor or ammunition. The initial days were spent on external examination and preliminary measurements. Teams meticulously documented the thickness of armor plates at various angles, the quality of welds where present, and the overall dimensions. Klaus found himself noting the relatively simple track tensioning system, the robust boogie assemblies of the VVSS suspension, details that spoke to ease of maintenance in the field. A stark contrast to the often fussy running gear of German tanks. Then came the moment of truth, the internal examination. Technicians, under the engineer's watchful eyes, began the process of opening up the Sherman. The engine deck was unbolted, revealing the heart of the machine. Expecting an inline diesel or petrol engine, a common configuration in German designs, the engineers were met with the sight of a massive, air-cooled radial engine, a Continental R975C1. Brant peered into the engine bay, a frown creasing his brow. A radial engine? In a tank? Most peculiar. More suited to aircraft, one would think. Klaus leaned in, examining the intricate network of cylinders and cooling fins. It is an aircraft engine, Doctor. A Wright Whirlwind variant, I believe. Modified for ground use. Peter Hess, ever the enthusiast, piped up. But Doctor, Herr Oberleutnant, think of the manufacturing implications. If they are already producing these engines for aircraft, adapting them for tanks would be a significantly simpler logistical exercise than designing an entirely new engine block from scratch. Brant stroked his chin. Logistics, yes. But what of performance? Longevity? The heat management for an air-cooled engine in a cramped tank compartment. He trailed off, clearly unconvinced. Yet, as the technicians began to carefully disconnect lines and unbolt components, the sheer accessibility of the engine began to impress Klaus. The entire power pack engine, transmission, and final drive was designed to be removed as a single unit, a feature that significantly reduced maintenance time. German tanks, with their longitudinally mounted engines and separate transmissions, often buried deep within the hull, required far more extensive disassembly for major repairs. Klaus ran his hand over a heavy-duty electrical connector. Look at this, Doctor. Simple, robust, clearly designed for rapid field replacement. No delicate wiring looms, no overly complex junctions. Brant nodded slowly, a glint of grudging admiration in his eyes. Indeed, a pragmatic approach. One might even say, elegant in its simplicity. Our Maybach engines, while marvels of precision, are not so readily serviced. The transmission, a 5-speed manual with synchromesh, was another revelation. Its robust construction and relatively straightforward gear train suggested durability, even under harsh conditions. German transmissions, particularly those in the Panther and Tiger, were notoriously complex and prone to failure, a consequence of trying to transmit immense power through intricate gearboxes. The engineers spent days meticulously documenting every component, comparing it to their own designs. They noted the use of standardized parts, the relatively low-tolerance manufacturing, which allowed for faster production, and the emphasis on accessibility. The turret, once opened, revealed a well-organized interior, with the gunner, loader, and commander having sufficient space to operate. The wet stowage system for ammunition, a design feature to reduce the risk of catastrophic fires, was also noted with considerable interest. Klaus found himself increasingly challenged in his initial dismissive stance. The Sherman wasn't a crude, hastily assembled machine. It was a deliberately designed vehicle, conceived with a clear understanding of the challenges of mass production and field maintenance. Its designers had not prioritized raw power or impenetrable armor above all else. but rather a balance of firepower, protection, mobility, and crucially, reliability and ease of manufacture. This growing realization was unsettling. Germany's engineering philosophy, driven by a pursuit of technical superiority, often led to magnificent but complex machines that were difficult to produce in large numbers and prone to mechanical breakdowns. The Sherman, by contrast, seemed to embody a different kind of superiority, one born of industrial might and pragmatic design. As the first major components were laid out on tarpaulins in the workshop, a stark contrast emerged. Next to the intricate multi-part German components, the Sherman's parts seemed almost agricultural in their simplicity and robustness. Yet it was precisely this apparent lack of sophistication that was beginning to earn a quiet, professional respect from the German engineers. The unveiling at Kummersdorf was not merely a technical exercise. It was a slow, dawning realization that the enemy had found a different, perhaps more effective, path to building a war machine. The dissection of the Sherman continued with an almost surgical precision in the Kummersdorf workshops. Each component, from the smallest bolt to the largest gear, was catalogued, measured, and analyzed. What began as a purely technical exercise for Oberleutnant Richter and his team gradually evolved into a deeper exploration of an alien engineering philosophy, one that challenged the very tenets of German design. Dr. Brandt, initially skeptical, found himself spending hours examining the Sherman suspension system. The vertical volute springs, while conceptually older than the interleaved torsion bar suspension of the Panther, were undeniably robust and simple. "Look at this boogie assembly, Richter," Brandt remarked, pointing with a caliper. "Each unit is self-contained. Damaged in the field, a crew can replace the entire boogie with relative ease. Our torsion bars, while offering superior ride quality, are a nightmare to service under fire. A single damaged road wheel can necessitate removing several others and potentially the entire torsion bar assembly." Klaus nodded, his initial disdain for the unsophisticated VVSS giving way to a grudging appreciation for its practicality. It speaks to a design intended for the average mechanic, not just a highly trained specialist. Simplicity, reliability, ease of repair, these seem to be the guiding principles. Peter Haas, who had taken to compiling detailed reports, added, "And the standardization, Doctor. We found identical bolts, nuts, and even minor subassemblies across different parts of the tank. Imagine the logistical advantage in parts supply compared to our own diverse inventory." This aspect of standardization struck a chord with the German engineers. Their own tank production, while producing technically superior individual components, suffered from a lack of interchangeability between models and even within different production batches of the same model. This led to a logistical nightmare, with specific parts often being unavailable when needed most. The Sherman, by contrast, seemed to be built from a common parts bin. A testament to American industrial foresight, the transmission, a constant source of trouble for German heavy tanks, was another area of intense scrutiny. The Sherman's Spicer transmission, a robust, manually shifted unit, seemed almost brutish in its simplicity compared to the complex pre-selector gearboxes found in Panthers. "It's less elegant, certainly," Brandt conceded, turning a heavy gear in his gloved hands. "But it is undeniably strong, and less prone to the catastrophic failures we've seen in our own designs when subjected to sustained stress." Klaus recalled reports from the front. Tales of Panther transmissions failing after only a few hundred kilometers, bogging down entire offensives. The Sherman's transmission, while perhaps not offering the same refined driving experience, was clearly built to endure. The gun, a 75mm M3, was also examined. While Klaus still maintained it was inferior to German tank guns in terms of penetration, he noted its high rate of fire and the ample ammunition stowage. The internal layout of the turret, particularly the power traverse system, was efficient and quick. They prioritize getting rounds downrange quickly, Klaus observed. Perhaps not the heaviest punch, but a continuous barrage can be equally effective. The wet stowage of ammunition was a particularly intriguing feature. The rounds were stored in water-filled bins within the hull, significantly reducing the risk of a secondary explosion if the tank was penetrated. This was a direct response to early Sherman losses due to brew-ups, catastrophic fires caused by ammunition detonation. A clever, if somewhat unconventional, solution to a critical battlefield problem, Brandt admitted. We've lost many crews to internal fires. This is a practical answer. The engineers spent an afternoon discussing the implications of the Sherman's design philosophy. It's a different war they are fighting, perhaps, Peter Haas ventured. One where the sheer number of machines and their ability to stay operational outweighs the singular brilliance of a single, powerful tank. Brandt sighed, removing his spectacles and rubbing the bridge of his nose. We have always striven for the ultimate weapon, the perfect machine. Our Tigers and Panthers are testament to that pursuit. But this Sherman, it is not perfect. Far from it. Yet, it embodies a different kind of perfection, the ability to be everywhere, to be easily repaired, to keep fighting. Klaus thought of his own designs. The meticulous calculations, the pursuit of optimal armor angles and maximum firepower. He had always believed that technological superiority would be the deciding factor. But the Sherman presented a counter-argument, that industrial capacity, combined with a pragmatic design focused on reliability and ease of use, could be equally, if not more, decisive. The conversations in the Kummersdorf workshops began to shift. The initial dismissiveness gave way to a grudging respect, then to a genuine professional curiosity, and finally, to an unsettling realization. The Americans weren't just throwing steel at the problem. They were doing so with a profound understanding of what made a tank effective in the chaotic environment of war. They understood that a tank that could be quickly built, easily maintained, and reliably kept in the fight was often more valuable than a tank that was technically superior but spent more time in the workshop than on the battlefield. As the last components were meticulously documented and carefully set aside, ready for reassembly and live testing, Klaus Richter felt a profound sense of humility. He had come to Kummersdorf expecting to confirm his preconceived notions about American industrial inferiority. Instead, he was witnessing a masterclass in pragmatic engineering, a philosophy that prioritized function over form, reliability over complexity, and mass production over individual perfection. The Sherman was not just a tank. It was a symbol of a different approach to war, one that Germany, with its increasingly strained resources and over-engineered machines, was struggling to comprehend, let alone counter. The implications of this realization would extend far beyond the Kummersdorf workshops, touching the very heart of German strategic thinking. The reassembly of the captured M4 Sherman was a deliberate, instructive process. Under the watchful eyes of Oberleutnant Richter, Dr. Brandt, and Lieutenant Haas, German technicians, armed with American wrenches and a newfound appreciation for the simplicity of the design, put the tank back together. Every bolt, every connection, every component was returned to its place, a mirror image of the meticulous disassembly. This hands-on experience only deepened the engineers' understanding of the Sherman's modularity and ease of repair. Once reassembled, the Sherman was prepared for the ultimate test, live trials on the Kummersdorf proving grounds. This was where theory met reality, where the perceived weaknesses and strengths of the design would be exposed under conditions simulating actual combat. A German test crew, specifically trained on the Sherman's controls, was assigned, their initial skepticism giving way to a growing familiarity with the foreign machine. The first tests focused on mobility. The Sherman, despite its higher profile and somewhat less sophisticated suspension compared to a Panther, proved surprisingly agile. It traversed uneven terrain with a steady, if not entirely smooth, gait. The radial engine, while noisy and somewhat unconventional, delivered consistent power, propelling the 30-ton tank across the testing grounds. The German engineers watched from an observation bunker, their faces grimly reflective. "It moves well," Brandt conceded, peering through a rangefinder. "Better than I would have anticipated. The broad tracks provide good flotation, even on soft ground." Klaus noted the ease with which the Sherman navigated obstacles. The VV-SES suspension, while simple, appears highly durable. It absorbs shocks without complaint, unlike some of our more delicate torsion bar systems that can be prone to shearing under extreme stress. Peter Haas, ever the detail-oriented observer, pointed out. "And notice the lack of track shedding, Herr Oberleutnant. Even over rough terrain, the tracks remain firmly in place. A common issue with our interleaved road wheel designs, particularly in muddy conditions." The real test of mobility came when the Sherman was put through a simulated endurance course, kilometers of varied terrain, including inclines, ditches, and sharp turns. German tanks, particularly the heavier Panthers and Tigers, often suffered mechanical breakdowns during such rigorous trials, their complex transmissions and engines straining under the sustained stress. The Sherman, however, endured. Hour after hour, it churned through the course, its radial engine roaring, its tracks biting into the earth. There were no breakdowns, no seized transmissions, no overheating engines. When it finally returned to the maintenance bay, covered in mud and dust, the crew reported no significant issues, only the expected wear and tear. Klaus felt a profound shift within him. He had expected the Sherman to falter, to expose its supposed structural weaknesses. Instead, it had demonstrated a resilience that was both impressive and deeply unsettling. "Remarkable," he murmured, almost to himself. "Truly remarkable. It simply works." Next came the firepower tests. The 75mm M3 gun, while not possessing the raw penetration of the German 7.5cm KWK-42, proved to be accurate and reliable. The power traverse system allowed the turret to slew rapidly, acquiring targets with surprising speed. The gunner reported a comfortable firing position and an intuitive sight. Live rounds were fired at captured German armor plates, confirming its capabilities against older Panzer III and IV models, and its limitations against the thicker, frontal armor of a Panther. But it was the speed of reloading and the volume of fire that truly impressed. The Sherman could put rounds downrange at a rate that outmatched most German tanks, a critical advantage in close-quarters combat. "They prioritize saturation," Brandt observed, as a volley of shells struck the target range, overwhelming the enemy with sheer volume, rather than relying on a single decisive blow. The ultimate trial, however, was the comprehensive reliability assessment. For weeks, the Sherman was subjected to a grueling regimen of driving, firing, and simulated battlefield repairs. It was intentionally driven through mud, across deep ruts, and over obstacles designed to challenge its suspension. The engine was run for extended periods, pushing its cooling system to the limit. The gun was fired repeatedly, testing the endurance of the breech and recoil system. Throughout these trials, the Sherman consistently performed. Minor issues arose, as they would with any machine, but they were invariably simple to fix, often requiring only basic tools and minimal time. The modular design, the robust construction, and the accessibility of components meant that the tank spent far more time operating than it did in the maintenance bay. One afternoon, after a particularly punishing endurance run, Klaus found himself standing beside Dr. Brandt as the Sherman rumbled back into the inspection bay. The tank was caked in mud, its paint scratched, but its engine still purred with a steady rhythm. Brandt, usually reserved, removed his spectacles and cleaned them with a handkerchief. His gaze fixed on the American tank. He turned to Klaus. his expression a mixture of professional awe and deep concern. "Richter," he began, his voice low, "we have built tanks of superior firepower. We have built tanks of formidable protection. But I must admit, with a heavy heart, that we have never built reliability like this. Not in our Panthers, not in our Tigers." Klaus felt a chill. The admission, coming from Brandt, a man who had dedicated his life to German engineering. The reports from Kummersdorf, meticulously compiled by Oberleutnant Richter, Dr. Brandt, and Lieutenant Haas, circulated through the highest echelons of the Wehrmacht and the armaments industry. They presented a stark, undeniable truth: the M4 Sherman, while not possessing the individual technical superiority of a Panther or a Tiger, represented a formidable challenge due to its profound reliability, ease of production, and battlefield practicality. The final debriefing was held in a stark, unadorned conference room at the Ministry of Armaments. Senior officers and leading engineers, their faces etched with the strains of a war that was increasingly turning against them, listened intently as Brandt presented their findings. He spoke of the radial engine's robust performance, the simple yet durable VV-SES suspension, the accessible modular design, and above all, the astonishing reliability demonstrated during weeks of continuous testing. "Gentlemen," Brandt concluded, his voice devoid of emotion, "the American M4 Sherman is not a tank we can dismiss. Its individual components are not as advanced as our own. Its armor is thinner in critical areas, and its main gun lacks the penetration of our latest designs. However, its genius lies in its holistic design. It is a machine built for war on an industrial scale. It is simple to manufacture, quick to repair, and consistently operational." He paused, letting the weight of his words settle. "We have focused on engineering perfection, on creating the ultimate fighting machine. The Americans, it appears, have focused on creating a machine that can be produced in overwhelming numbers and kept in the field with minimal effort. This, I submit, is a different and perhaps more effective form of battlefield superiority." Klaus Richter, standing beside Brandt, observed the reactions in the room. Some officers shifted uncomfortably, clearly unwilling to accept that an enemy machine, so outwardly unsophisticated, could be so effective. Others, particularly those who had seen the relentless tide of Allied machines on the Eastern and Western fronts, nodded grimly. They understood that quantity, when coupled with reliability, possessed its own devastating quality. After the presentation, Generalmajor Guderian, known for his pragmatic and often blunt assessments, addressed the room. "Dr. Brandt, Oberleutnant Richter, your findings are sobering. We have always prided ourselves on our technological edge. But if the enemy can field 10 reliable tanks for every one of our technically superior, yet fragile, machines, then our edge is blunted by logistics and attrition." The conversation then turned to the implications for German tank production. Could they adapt their own designs to incorporate some of the Sherman's principles of simplicity and modularity? The answer, as many in the room knew, was complex. German industry was already strained, constantly battling material shortages, bombing raids, and a dwindling skilled workforce. Rewriting entire design philosophies and retooling factories in the midst of a total war was a monumental, perhaps impossible, task. Klaus reflected on the journey from the muddy fields of the Eastern Front to the sterile conference room. His initial disdain for the Sherman had been systematically dismantled by hard evidence. He had seen firsthand how the American engineers had prioritized different values. Not the pursuit of ultimate ballistic protection or firepower, but the pragmatic goals of mass production, crew survivability through practical means like wet stowage, and above all, operational readiness. The contrast with German engineering was stark. The Panther, a magnificent machine in its capabilities, was plagued by a complex transmission and drivetrain that frequently failed. The Tiger, an armored behemoth, required meticulous maintenance and consumed vast quantities of fuel and spare parts. Both were difficult to produce in the numbers required to stem the Allied tide. The Sherman, by contrast, was a workhorse, a dependable tool of war. Forged in the vast, unmolested factories of America. Peter Haas, who had been listening intently to the discussions, approached Klaus later that day. "It's a different kind of war, isn't it, Herr Oberleutnant?" he said, his young face thoughtful. "Not just about clever designs, but about the ability to build, to maintain, to sustain." "Indeed, Lieutenant," Klaus replied, looking out a window at a distant, hazy Berlin skyline. "It is a war of industrial might, as much as it is a war of machines and men. We built monuments to engineering. They built tools for victory." The experience of examining the Sherman left an indelible mark on Klaus Richter. It instilled in him a profound humility, a recognition that engineering excellence could manifest in forms he had previously dismissed. The pursuit of perfection, he realized, could sometimes lead to fragility, while an embrace of pragmatism could lead to overwhelming strength. The captured Sherman, now likely destined for further study or perhaps even a propaganda exhibit, stood as a silent testament to this realization. It was not just a tank. It was a symbol of a different industrial philosophy, a testament to the sheer scale and ingenuity of American production. German engineers had tested it, probed its every secret, and in doing so, they had been forced to admit a humbling truth. They had never built reliability quite like it. This wasn't merely a technical admission. It was a profound acknowledgement of a strategic disadvantage, an echo of the industrial might that was slowly, inexorably, grinding the Third Reich towards its inevitable defeat. The lessons learned from the Sherman would linger long after the war, influencing future tank designs and shaping the understanding of what truly constituted a successful war machine in the modern age.